Now, how we can deal diode in circuit, okay, that we learned today. So diode can be used in the circuit with some approximations, okay. So there are three models, okay, based on which we will deal the diode in the circuit. First is ideal diode model. Okay. Second is constant voltage model. Constant voltage model. And the third one is piecewise linear model. Okay. So we will take one model at a time. Okay. So let me start with the ideal diode model. Okay. So we know the IV characteristics of PN junction diode. We already discussed that if I plot I versus V plot for a diode. Okay. So diode current in forward bias, diode current increases exponentially. And we have seen that in reverse bias, a very low saturation current flows, okay, until the breakdown happens. Now, with this kind of IV characteristics, it is difficult to use analyze circuit which contain diode, okay. So because we have to give some diode in the circuit is there, so we want to know what is the voltage across diode, okay, how much current is flowing through a diode. So in order to understand this one, we have to approximate this IV characteristics, okay. So if I want to approximate in the ideal diode model, what I can do, so this is the cutoff voltage, and this is your reverse saturation current. Okay. Now I know in forward bias there is a very high current comparison to this reverse bias, so I can neglect this current. So I can assume that when you apply any reverse bias to a diode, okay, no current flows through the diode. That means diode can act as an open circuit for reverse bias voltage, okay, because this approximation, okay, you can understand this current, okay, this current is very low, reverse saturation current is very low, okay. So we can assume this current is low, and we can approximate the behavior of diode as an open circuit in a reverse bias. Similarly, if you see here, the current is suddenly increasing. If I slightly increase after cutoff voltage, if I slightly increase the voltage, okay, the current getting shoot. Okay. So now in ideal diode model, what we assume that this cutoff voltage is 0. That means even we don't require any voltage drop across diode to conduct a current. Okay. So this IV characteristics was approximated by this IV characteristics. Okay. So what is the meaning of this one? So whenever diode is in forward bias, okay, a current will flow through the diode, okay, but the voltage drop across diode will be 0. Okay. That means in forward bias we will take diode as a short circuit. So what we can show, so if diode is in forward bias, okay, suppose this is my diode, okay, okay, and I'm applying a voltage diode, okay, a positive voltage. So when diode is forward bias, so in circuit I will replace this diode by a short circuit, okay, and whenever
Sir, sound is not coming, sir.
You want to message?
so in forward bias, if diode positive terminal is connected with positive voltage, then it will be we'll assume diode is a short circuit. If diode positive terminal is connected to minus voltage or minus terminal of battery, in that case, what we'll assume? We'll assume the diode as an open circuit. Okay. So this is the model of diode in the circuit. So what I can write here, if ID is flowing through the diode, then VD, okay, across diode is 0. Okay, so this is VD across diode is 0. Okay, similarly, if VD is negative across diode, okay, then ID is 0. Okay, the current flowing through diode is 0. That means diode can be replaced by a open circuit. Okay, so any question? So whenever I will use diode in circuit, if I find diode is forward bias, you have to first find whether diode is a forward bias or reverse bias. Once diode is a forward bias, I will make it short circuit. Okay, and if diode is reverse bias, I will make it open. So let me demonstrate this by example. So we are doing ideal diode model. So for example, I have a question. I have a diode. Okay, and this diode is connected by a sinusoidal voltage, and here we have a resistance. So the resistance value say R. Okay, and the value is the resistance, and I am measuring the voltage across the diode. Okay, now I'm applying a sinusoidal voltage. Okay, say my Vs. Okay, Vs is your Vi sin omega t. So now I know my input. Okay, Vs or Vi. So I know this with time. I'm applying some signal like this. Okay, now I want to measure this voltage. So say I'm measuring this output. Okay, so now this is a sinusoidal curve. Okay, so that has a positive cycle as well as negative cycle. Okay, what is mean the positive cycle? In positive cycle, this terminal will be plus, this terminal will be minus. Okay, so when this terminal is plus, okay, so my diode will be in forward bias or reverse bias? Forward bias. Okay, that means I can say that from time, okay, 0 to t by 2 time period of this. So this is total time period. This is time t by 2 and this 0. So when time is 0 to t by 2, my diode is forward bias. Okay, so diode is forward bias. Okay, so when diode is forward bias, what I can do, I can replace this diode by a short circuit. So this circuit will be now like this. Okay, you can do it there itself. R. Okay, and this is your voltage. Now this is my, again I'm applying my Vs. Okay, sinusoidal. So now because this is a short circuit, so the drop across diode, okay, if I call it Vd, okay, if I call it Vd, so in this case your Vd will be 0 because the short circuit. So whatever the voltage is applying here, that will come to here. Okay, are you getting this one? So for example, if I now draw again my input and output, so this is my
Means what, sir?
pardon?
VD means
VD is a voltage drop across diode. Okay, so voltage drop across diode will be 0. So whatever voltage I apply in positive cycle, all will come here. So this is my V input or Vs, and now if I draw V output, okay, so in positive cycle what will happen?
Same graph.
Same graph will come. Okay, so जो भी voltage में लगाया positive cycle में, that will come to here because here drop is 0. Okay, now what will happen in negative cycle? Okay, if diode, if I go from t by 2 to t, okay, this time will be minus and this time will be plus terminal, isn't it? So now diode is forward bias or reverse bias?
Reverse bias.
Reverse bias.
Reverse bias. Okay. So what you can make in ideal diode model, you can make it as open circuit. So this is open circuit. Okay. तो इन द क्वेश्चन इट विल बी गिवन, आपको बताया जाएगा कि डायोड फॉरवर्ड बायस है कि रिवर्स बायस है, मतलब आइडियल डायोड है कि कांस्टेंट वोल्टेज मॉडल है या पीस वाइज लीनियर मॉडल है. सो आइडियल मॉडल में यू हैव टू रिप्लेस दिस बाय शॉर्ट सर्किट. नाउ कैन यू टेल मी व्हाट इज द करंट इन द सर्किट?
Zero.
What
Zero.
is the current? Current is zero in the circuit. Okay.
Zero.
So if there's no current flowing in the circuit, here output will be what
Zero.
will the output? So output will be also
Sir,
zero.
wait a moment, sir.
Hmm?
Wait a moment.
Yeah.
The output will be 0.
So I want to write my V naught. What is a V output? So I know my V output is like V.
Sir, screen लग रही है.
If my time is between, huh?
The lagging sound is lagging, sir. Voice is
Okay. Or maybe internet issue. So tell me once if it happens frequently, please let me know. Okay. Now I want V naught output will be your 0 if my time period is between T to T. So if the reverse bias, if the negative cycle is coming, my output will be 0. Okay, so that means this time my whatever voltage I'm applying here, that voltage will come to here because there's no current in the circuit. Okay, so whatever voltage I apply here, voltage is 0. So whatever voltage I apply here, that will come here, Vs. Now let me give one more example.
Sir, there is no closed loop now. So
Hmm.
how in that case that VS will come completely?
भाई अभी ये करंट फ्लो नहीं हो रहा है. ओके,
Yes.
करंट फ्लो नहीं हो रहा है तो यहाँ पे कोई ड्रॉप होगा नहीं, तो इसका मतलब यू कैन अंडरस्टैंड whatever voltage is here, that voltage is here. Okay, when it is negative, okay, and no current is flowing, that means you can assume that this point and this point are same. So whatever voltage I am applying, that coming here because here voltage drop is 0. voltage तो आ सकता है ना ओपन सर्किट में, voltage can be no open circuit, voltage drop can be across the open circuit also. Current will not flow. Okay.
Okay, so across the diode, the basically voltage will be there, VS.
Yes. Okay.
So why are showing the graph 0?
So I am showing output. I am drawing output. I am not drawing the output across diode. I am showing this, drawing this B output. Okay. So this is 0 because there is no current in the circuit. No current means IR is 0. Okay. Are you getting this one?
Yes, sir.
Okay. So we'll do couple of more problems, then it will be clear to you what exactly meaning of ideal diode model. Now suppose I plot, this time I'm applying a constant voltage.
सर स्क्रीन फिर से लैग हो गई, ब्लर हो गई है पूरा मेरे साइड से.
Other people's
Yes, sir.
screen
sir.
visible to other people also
No,
No,
that's
sir.
lagging.
lagging and
Okay. So this is 10 volt. See, if it's lagging for all, then the problem is from our side. If it is lagging for a few students, then there'd be maybe internet issue with you with people. Okay. So this time I'm applying this 10 volt battery here, and this is my resistance R. Okay. Now I want to calculate how much current is flowing in the circuit. Okay. So this diode is forward bias or reverse bias?
Forward bias.
Okay. So diode is forward bias. Okay. So forward bias means now what I can do? I can replace this
Short circuit.
short circuit. Okay. So if this is a forward bias, I can replace this diode by a short circuit, and this is my R. Okay. And R value also given this question. R value is given 1 kilo ohm. This is 1 kilo ohm resistance. Okay. And this VD is already given 10 volt. Okay. So what is the value of current in the circuit? ID. If you know ID,
10 milliampere.
ID will be what? VD 10 upon 1 kilo ohm. Okay, 1 kilo ohm. That is, and that is will be your 10 milliampere. Okay. Now suppose if I replace this diode, okay, I make it this diode opposite to this one. If I this is third question. If my diode is like this, and this is my 5 volt. Okay. So in this case,
Sir,
yes, what will be the
how do you
ID?
calculate ID value, sir?
Which value?
ID value.
ID, how do you calculate? You have 10 volts voltage given, voltage source is given, total voltage divided by total resistance.
Okay.
Okay. Okay.
Okay, sir. Hold, sir.
Okay. So can you tell me in this circuit, if I say this is my V output, okay, and this is my VR. Okay. So can you tell me how much current is flowing in the circuit? What is the voltage drop across R, and what is the voltage drop across diode? Can you tell me in this particular question? How much current is flowing in the diode?
0.
Sir, VR equal to 5 volt, VD equal to
Anyone
0 volt.
else? VD equals to 0 volt, and VR
And
equals to
VR
5 equals
5
to
volt.
5 volt. And how much is I?
0, sir.
0.
I is 0. Okay. So if I is 0, then how can you say VR is 5 volt?
Sorry, sir. VR also 0.
Okay, very good. So now now you can see the diode is reverse bias. Okay. How to find diode is reverse bias? Okay, you can make it open. You can make it diode open and see how much voltage is coming. So this is a negative terminal battery. Okay, this is negative terminal diode. This is positive terminal diode. Now you can see if no current is flowing, all the voltage getting drop here. So here you have 5 volt. This is minus volt. Okay, that means your diode is now reverse bias. So whenever diode is reverse bias, what you can make it, you can make it open circuit. Once the circuit is open, the current flowing in the diode is 0. Okay, if current is 0, the voltage across VR also 0. And if you want to say what is VD, so VD in this way, if you measure this way VD, this will be your 5 volts.
Sir,
Hmm.
there will be no resistance, no voltage drop across resistance. In between, there is 1 kilo ohm resistance. So the voltage will be.
वोल्टेज ड्रॉप क्यों होगा जब करंट फ्लो ही नहीं कर रहा है? Okay, if there is a no current in the diode, I is 0, so VR is what? Your VR is IR. Okay, now I is 0, so your VR will be automatically 0. So there's no drop, no drop. Okay, so whatever voltage is coming, that will come to here.
Okay, sir.
Okay, so if I ask you to apply KVL, you can apply KVL. I is 0, so whatever voltage come there, that will come to here. Okay, now
Sir, if I is 0, then VD
Yes.
also 0, na, sir?
VD how can be 0? VD cannot be 0, na? See, if this 5 volt is there, now here this is 0, so where this voltage will go? You can always find the voltage across here also. So here V0. Here 5 volt. Here is a 5 volts. Okay. Now
Yes,
here
sir.
from here to here there is no loss, so it will come as it is here. Are you getting?
Yes, sir.
So suppose you want to write KVL. So how you write? -5 plus VR, okay, plus VD equals to 0. Okay. Now VR is what? VR is what? Your I into R plus VD equals to 0. Now I is 0. Okay, this becomes 0. This become VD. So what is your VD? VD become 5 volt. Is it clear?
Yes, sir.
Okay. So this is 3 volt battery. Okay. This is 200 ohm resistance and this is 100 ohm resistance. This is the plus, this is the minus. Okay. So you need to find the current in the circuit. You have to find current in the circuit. Okay. I. So in this particular question, diode is forward bias or reverse bias?
Forward bias.
Okay. Any other person? Is
Forward
Forward.
bias.
forward bias. Okay. Forward bias. So what I can do, I can replace this by a short
ऐसे
circuit.
देख रहा है ना उसका ये
हाँ?
बड़ा टर्मिनल किस मींस पॉजिटिव आ रहा है तो वो फॉरवर्ड बायस ऐसे ही देख रहे हैं ना
हाँ, अभी आइडियल डायोड है, यहाँ पॉजिटिव वोल्टेज है. ओके. यहाँ पे कुछ ड्रॉप होगा नहीं, तो इसका मतलब करंट तो फ्लो करेगा ना सर्किट में. So whenever current is flowing in the circuit, that is diode, you say it's forward bias. Or the second method, if you want to know whether diode is reverse bias or second or forward bias, you just make it open. Just make it open and check how much voltage drop across this diode. Now, if you make this open, again the current will become 0. So whatever voltage is there, that will come to here. That will tell you your diode is forward bias. Are you getting my point? If you want to see your diode is forward bias or reverse bias, okay, you just make it open. You see, just calculate the open circuit voltage. How much voltage is coming here? Like you used to calculate VThevenin. Okay, so how much voltage is coming here? So if you see this voltage, no current is flowing. So whatever voltage is here, that voltage come to here. That means now positive terminal, you have 3 volts battery. Okay, in open circuit case, that means your diode is forward bias. You cannot make it open circuit. Okay, so now you can. This is a short circuit.
So 10 milliampere.
Okay, now you want current. So you have voltage is 3 volts and the current resistance is 300 ohm. Okay, this become 1 upon 100 ampere. That is
10 million.
10 milliampere. Okay. Now let me give you one more example. So you have a 200 ohm resistance here. So now I'm replacing it by 600 ohm. Okay. Here I have a resistance of 300 ohm. Okay. Here I have a diode. Okay. Okay. So in question you're asking here also 100 ohm resistance. So find the current ID in the circuit. Okay. So I'm going to solve this circuit. Okay. Some different methods. So please tell me what is diode is forward bias or reverse bias?
Forward bias.
Okay. Of course, it is a forward bias because some voltage plus is there. After drop, some voltage will come. This voltage, this diode require only 0 voltage because ideal diode. positive voltage there that will drive this diode as a forward bias. Okay, so we can say, okay, at least some volt out of 3, some voltage will come. Okay, if you want to calculate exactly, just make it open. You know how much voltage is coming when it is open. Okay, so if something positive voltage is coming here, that means this diode is forward bias. You cannot make it reverse bias. Okay, so this is forward bias. So now if it is forward bias, what I can do, I can replace this diode by a short circuit, isn't it? Okay, now you can calculate the current. Now if you want to calculate the current, you should know this current, total current IT, isn't it? So how to calculate total current? Total current IT is total voltage upon total resistance, and total resistance how much? 600 plus
100 and 300 in parallel.
these two resistances are parallel. So
300 by 4.
300 into 100 upon 400. Okay, now if you solve this one, 20 gone, is gone, 1 here, 75. Okay, 3 upon 675. Okay, if you solve it further, how much it come? 2. Okay, 2 1,225. Okay, ampere.
So 3.3 milliampere.
Okay, 3.3 milliampere. Let me check. Okay, whatever. Are you sure 3.3? Okay. Okay, just let me make it 9. Okay, otherwise my question, make it 9. Okay, so this become now 9. Okay, so 9. So how much will come now? Tell me how much will come now if it's
3
9.
by 225.
Okay, so if I do it 9, this should come to 1 upon 75. Okay, 1 upon 75. So it is 1. Okay, 7 then 63.45. Okay, so 1 by 75 ampere. So this is my total current. Now I want current ID. So ID will be how much? Total current is 175 into, I want the current in this branch. So I'll take resistance of opposite branch, current division. I'm applying now current division. So current, I will take resistance of 300 divided by total resistance
10 milliampere.
400. Okay, so this is 1, this become 4, and this become 1 upon 100, and that is equal to 10 milliampere. Okay, so this is the one method to solve this kind of question. Method 1. Okay, now let me explain method 2. Okay, same question. If you don't understand like this, you replace again, right here diode. So here what I have done, here I have calculated total current. Okay, and by current division I have find out how much current is flowing across the diode. So this comes out 10 milliampere. Okay, so now let me do it some other method. Now second method. Yes.
वो 400 से क्यों डिवाइड करा?
हाँ?
400 से क्यों डिवाइड करा?
करंट डिवीजन कैसे लिखते हैं बेटा? करंट डिवीजन कैसे करते हैं हम लोग? अगर मुझे दो रेजिस्टेंस है R1 R2, तो जो जिसमें फ्लो हो रहा है उसका अपोजिट रेजिस्टेंस लेते हैं, डिवाइड बाय टोटल रेजिस्टेंस. करंट डिवीजन कैसे करते हैं? करंट रेजिस्टेंस कैसे करते हैं? ये था हमारा डायोड, यहाँ पे 300 है, यहाँ पे 100 है. ओके, आई वांट करंट इन दिस ब्रांच. ओके, say I dash, or I did this case, I total current I is coming here. So if I want ID, how do I write? I write this one, total current IT. I want current in this branch, so opposite resistance 300, and then sum of the resistance. Parallel nahi hai bhai. This is for you're not revising. Okay, you don't remember the formula. We don't have to take total resistance. We will take sum of the resistance here.
Okay.
400. Okay. Now second case, what I can do, what we learn, we can apply Thevenin theorem. So before this diode, okay, before this diode, I can make the circuit open. Okay, I'm calculating the equivalent circuit of this whole circuit. Okay, are you getting my point? I'm calculating equivalent circuit before this diode. So if I want to calculate equivalent circuit with Thevenin, what should I do? Suppose my circuit is like this, 600 and 300. This is 600 and this is 300 ohm. Okay, I want to calculate how much voltage is coming here. Okay, so I make this open circuit.
VT is equal to 3 volt.
9 volt. So if I want VThevenin, so VThevenin will be how much? 9 upon
3
900.
volt. Sir.
Okay, 900 upon 9 into 300. Okay, that will be 3 volt. Okay, and what will be the RThevenin? What will be RThevenin? So for RThevenin, I have to make this short. So now find RThevenin. Okay, so now these two resistors are in parallel. So my RThevenin will be what?
200.
600 into 300 upon 900. Okay, this becomes 3. So this becomes 200. Okay, so 200 ohm. So now I can replace this circuit, okay, by a VThevenin, that is 3 volt battery, and series I have a 200 ohm resistance. Okay, so this is the equivalent circuit of this circuit. Okay, and then we have a diode. Okay, and then we have 100 ohm resistance. Okay, so this is my 3 volt battery. Okay, now again same thing, you want current, this I current in the circuit ID. So this is now forward bias, so you can replace by a short circuit, isn't it? And again if you calculate, ID will come what? ID will come 3 volt upon
300.
300. So again you are getting 10 milliampere current. Okay, now this is a method. Now what you can do directly, you can open this one also. Okay, you like we used to calculate VThevenin of a circuit. Okay, so far I was not doing like that because this is ideal diode model, there is no voltage drop. Okay, so if this is not ideal diode model, some voltage drop is there, then first we'll check that much voltage is coming here or not to make diode forward bias. So the third method, okay, like similar, and you should use that method frequently. What is the third method? This method is clear, na? It is method clear?
Sir, means in this method we also only consider it as a closed circuit, na, across the diode.
What not flowing? Current is flowing, na?
That
Forward bias, na? It is forward bias. Okay. Now I can do it. This is some different way also. Okay. Now I can find that VThevenin across this open circuit. Okay. I want to find what is VThevenin, and this is my load. Okay. I'm dealing in making this like a load. Okay. And I'm calculating how much voltage is coming here and what is the equivalent circuit of this one, this whole, making this as a load. Okay. So now can you tell me what is VThevenin?
KVL लगा के हो जाएगा.
So if you want to calculate what is VThevenin, okay, so this so what is voltage coming here? Basically you want to find what is the voltage coming here. In this point there is a open circuit, so your current coming here, current is going like this, so no current is flowing here, so there is no resistance drop here. Okay, so no resistance drop means this voltage same, this is also same, this is 0 voltage. Are you getting? Okay, because here open circuit, so this terminal is, you can assume, directly connected to this one. So if you want to calculate VThevenin, that means you want to find this voltage VThevenin, and this is 0, so you want the difference. Basically this difference is VThevenin. So what is VThevenin? Again, if I solve this one, what is the VThevenin?
3 volt.
Okay, again coming 9 divided by 900 into 300. Okay, again it's coming 3 volts. Okay, now if I find RThevenin here, How much is coming? Okay, how much will come RThevenin? So for RThevenin, you have to make this short. Okay, so these two are parallel. Okay,
Yeah.
and this is series. So this become parallel. So how much? 600 parallel to
300
300 plus
300 ohm.
100. This become 300 ohm. Okay, that means now I can replace this circuit by a new circuit with Thevenin. Okay, with Thevenin 3 volt, and the resistance is 300 ohm, and then you have a load. You have a diode. Okay, or you can make it here also, what if you want. This is your diode. Okay, now you can want current ID. Again, you can replace the diode by a short circuit. Okay, you can replace diode by a short circuit. So again, you will be having ID equals to 3 upon 300. Okay, so 10 milliampere. Clear? Okay. Any doubt in this question?
So means how are means how VTH and RTH
How means what? We are making it open. Na? We are assuming this is a load.
Yes.
And rest of the circuit, we are calculating with Thevenin.
Okay.
Okay. Okay. Let me give one more question. Okay. Forum resistance here. Forum resistance here. Okay. This is diode. This is a 1 ohm resistance here. Okay. And here you have 2 milliampere current. Okay. Now I want to solve this question. Okay. So I want to find out, okay, how much is current flowing, okay, through the diode. I need to find how much is current flowing through the diode. Okay. So there are many methods. Okay. You can try methods. Okay. So what I'm trying, see, as soon as I see this voltage here and resistance series, and there is resistance parallel. Okay. So what I'll do, I will try to remove this resistance first. Okay. So this is the equivalent to VThevenin, and this is the VThevenin voltage, and this is the RThevenin. Okay, so I can always replace this VThevenin, okay, source by a voltage source by a current source using Norton theorem. Okay, so if I apply Norton theorem here, okay, I can replace this voltage and resistance by a current source and a parallel resistance. Isn't it? Now you tell me what is the value of current?
2.5
Okay.
ampere.
So if you want current, you simply divide 10 by 4, that is 2.5 volts. And what is Rn here?
4 ohm.
But the same R will come here. This is 4 ohm. Okay. And then you have a diode here. This one here. And you can convert this in a Thevenin circuit, because I want to make everything even series. I want to remove this parallel circuit. So if I want to convert this in a voltage source, okay, this current source in a voltage source, again I can apply source transformation. I can convert current source into voltage source. Okay, so what is the voltage value here? V equals to IR. Okay, so I is 2 milliampere and resistance is what? This is just 1 minute. 1 milliampere to milliampere or ampere. Let me check. Okay, so this is ampere. Okay, this source is ampere. So this will give me what? This will give me now 2 volts. Okay, V into I, 2 volts. Okay, so I can write here this as a 2 volts and resistance will be same 1 ohm. Okay, now I can simplify the circuit further. This is the 4 ohm in parallel. So the equivalent of these two resistance will be how much?
2
2
ohm.
ohm.
2 ohm. Okay, so I can remove this one because they are in parallel. So I can replace this diode by a 2 ohm resistance. Okay, now this is a current source and there is a resistance parallel. Again, this is a Norton circuit. I can replace this Norton circuit by again a Thevenin circuit, isn't it? Okay, so if I again replace this by Thevenin circuit, this voltage will be how much? Current in current is 2.5, current into
5.
5 volts. So I can replace this by now again 5 volt battery. Okay, and then I am replacing this resistance here in series 2 ohm. Okay, now everything becomes series. Now you can easily find how much current is flowing in the circuit. Okay, now here you have 2 volts and here you have 5 volts. So of course this diode is in forward bias.
Forward.
Okay, because here you have more voltage, here is a less voltage. So effectively this diode is in forward bias. So now you can calculate the current. Okay, make it short circuit. Okay, so this diode will be replaced by a short circuit. Okay, and you can calculate how much ID is flowing in the circuit. So how much will current will flowing? So if you apply KVL -5 plus here it will be 0. So 2 plus 3 ID. Okay, and plus 2 volts equals to 0. So you can write 3 ID equals to how much? -5 plus 2. How much? 3 and ID will be
1 amp.
ID will be your 1 ampere. Now I have solved this some particular method. You
Sir,
can use whatever method you know. You can take here VThevenin. Okay, whatever way you know you can apply the method and you can calculate this current flowing in the circuit. हाँ बोलिए.
सर बीच में मेरा इंटरनेट चला गया था, तो
हाँ.
मुझे ये बताइए यहाँ 5 वोल्ट और 2 वोल्ट कैसे आया? 2 एम्पियर था ना?
2 वोल्ट है ना यहाँ पर. ये 2 एम्पियर है. ये नॉर्टन सर्किट है. Okay, again I can convert Norton circuit into VThevenin circuit.
डिवाइडिंग करंट.
So VThevenin में RThevenin change होता नहीं है. RN and VThevenin are same. So this is 1 ohm and we voltage can become 1 to 2 volts. So whenever there is a voltage source, okay, a current source and parallel resistance, you can always convert current source into voltage source. Okay, so this is called source transformation technique. So you can use to simplify this technique whenever you feel that some resistance coming in parallel and you want to remove, then you can apply this source transformation technique and simplify the circuit. Okay, so I have done this question with some particular method. Okay, you can use any other technique, whatever you know, your analysis. We have done so many techniques and try to solve this with your technique. Okay, so I'm giving you homework. Try some other method also. Send me this solving by some other method. Answer I have given you 1 ampere. Answer is 1 ampere. Okay, any question? Okay, shall I repeat again this one or is it clear?
Clear, sir.
So whenever diode in the circuit, your first job is to find out whether it is a forward bias or reverse bias. Okay. Now let me start the diode application. Okay. So diode first application, we are discussing your half wave rectifier. Okay, half wave rectifier and full wave rectifier. So first we already discussed one time. Okay, let me discuss one time more. Okay, so here I'm applying, say, a V input, okay, which is a sine wave, okay, t by 2 and 0, okay, and here I'm saying this is my load resistance RL. Okay, so we have already seen when I apply input, okay, B input, I get B output like this only. I got B output like this. Okay, so I told you your V output is like V input for 0 to t by 2, and your V0 is 0 whenever you have t by 2 t. Okay, so now I want to calculate what is the DC voltage, average DC voltage. Okay, what is the average of this V naught throughout this cycle? Okay, so what is the formula for average voltage? How to calculate the average of a function?
Sir, V input into T by 2 plus 0 into T by 2 by total time.
Any other one? How can you rise?
Integration 0 to t v dt.
Yes, very good. Okay, so if any function is there, if I want to find out its DC voltage, okay, I can do VDC as, okay, or any function I can write any function average. Okay, that is 1 by t 0 to t ft dt. Okay, so here I want d, so I can write 0 to t, okay, v naught dt. Okay, now if I write this 1 by t, okay, I know, so 0 to t by 2, my v naught is how much? V naught is what? Just now I have drawn this curve. Okay, so my v naught is equal to v input, that is v input is what?
V sin omega t.
Okay,
Omega
so
t.
v input is Vm sin omega t, Vm sin omega t. Okay, 0 to t by 2. Okay, so this is my output. I have this one, this is sine wave in this period, and here I have a 0, and this is my V output. So I can write Vm sin omega t dt, and here t by 2 to t I have a 0 output, so I can write 0 dt. Okay, now if I want VDC, so this will be 1. Okay, this will be Vm, will come out if I differentiate integrate sin omega t, so this will come out Vm upon t, okay, cos omega t upon omega 0 to t by 2. Okay, and if you solve this one, how much it come?
Minus will
Vm
come.
e 2 pi by t. Okay, if I put limit here t by 2, okay, so t by 2, that means cos 2 pi upon t into t by 2. Okay, and minus sign will also come here because this is the sign, so the cos will come minus. Okay, minus here, so this cos pi minus cos 0. Okay, so if I solve this one, this will come -1, okay, -2, -1 is plus, so this will come 2 Vm upon 2 pi, 2 cancel, so this will be my Vm by pi. Check it, is correct or not? So the VDC for half rectifier is your Vm by pi. Okay, so if I calculate VDC, this should come Vm by pi. Correct? Any issue with this one? So you know how to calculate now VDC. Okay, I have done this for half rectifier. Okay, now same thing we'll do for full wave rectifier now. So I just integrate sin omega t to this cos omega t upon omega. Okay, so this was your, हाँ बोलिए.
टी कहाँ कैंसिल हो रहा है ओमेगा का? टी कहाँ कैंसिल हो रहा है ओमेगा का?
Omega is 2 pi by t ना?
Yes.
Omega is 2 pi by t. Okay. Now let me draw one more circuit. Okay. So first we'll do basics of this rectifiers, and we'll do some problem based on this rectifiers. Okay. And then we will take clipper clapping, Zener diode, okay, and other applications of diode. Okay. So this is your bridge rectifier. Okay. Now I'm applying a V input here. V input here. Okay. V input is again Vm sin omega t. And I am measuring my voltage here. I am measuring my voltage here. And this is my load resistance RL. Okay. Now you tell me what is the function of output. Okay. What is the output function? Okay. So if I send a sine wave, okay, V input is equal to Vm sin omega t. Okay. Now what is the V output? Okay. So for first cycle, okay, I'm applying here input. For positive cycle, this term will be positive and this will be negative, isn't it? So what will happen? This diode will be short circuited, okay, and this will be your open circuit. Okay, again this diode will be also open voltage or open circuit, because you are applying positive here. Okay, here there is no drop, so whatever voltage coming, okay, see, look it properly. I am applying voltage here, this voltage is coming here, there is no voltage drop here, so voltage come here. Okay, so current will flow like this here. Okay, current will flow like this, and then current will go here in the circuit because this is open. Okay, again your current will flow from here to here, and then it will go to negative. So current starting from positive, okay, current going like this, this is open, current will go here, and then the current will go from this is also short circuit. Okay, because it's negative connected to negative. Here this negative connected to positive, this is open, this negative connected to negative. Okay, and here also voltage drop is come plus minus plus minus. This is a short circuit. This is a short circuit. So your current is going in here, your current going load like this. Okay, so now whatever current you are applying, okay, is going in this direction. So I am getting what, like this. Okay, whatever voltage I am applying, I am getting same input at the output, isn't it? Because there is no other loss here in the circuit. Voltage कहीं पे drop नहीं हो रहा है. All are ideal diodes. So no voltage drop here. Okay. So whatever voltage coming directly coming to here. Here no drop. So whatever voltage you're applying, you're getting that voltage in output. Okay. Now reverse cycle, what happens? So this is clear. This point is clear or not? I can repeat if someone wants to repeat me. Okay. Now, if you're applying reverse bias, negative cycle. So negative cycle, what will happen? Second time in negative cycle, what will happen? This will become negative, this will become positive. Okay. So second cycle, this become positive. So this become reverse bias, this become forward bias. So this becomes short and this become open. Okay. Now here you have plus voltage. Okay. This become open circuit, second class. So your current will come here. Now this time current will come opposite direction. So current is coming like this. Okay. Current is going like this. And again, current is going in same direction like this. Okay. This positive. And from here, this will be short and current will go again back to your negative terminal. So again, you're getting voltage in same direction. What you get earlier. Okay. So if I say this is my plus, this is a minus. Okay. So this is my positive voltage. Again, I'm getting positive voltage. So I get my output is like this.
So reverse direction we are getting ना across RL.
कहाँ रिवर्स में कहाँ मिल रहा है? करंट तो वापस इसी डायरेक्शन में जा रहा है. अभी जो पुराना वाला डायरेक्शन है. Okay. Now your current is coming like this here. Okay. From here to current coming like this here and again going this direction. This is open. But this is now plus positive here. This is positive. This short circuited. This is open. Okay. So current again going this direction and going here. This one. So we have to see how current is going in load. So load current always in same direction.
Yes, sir. Clear.
Okay. So in the load current is going always same direction. So you're getting always voltage in same direction. What is the polarity of this voltage and this voltage is same. If current comes this way, then you have to take negative, this negative. Okay. So now once you know the V output, okay, you can write this as a function. Okay. So I have a V naught equals to Vm sin omega t. Okay. For 0 to t by 2. Okay. Now if I want to write V naught for t by 2 to t, how much is come? What is the function?
Vm sin omega t.
So I should write plus or minus here.
Minus.
Oh, sir. It will come plus only. Same direction. Plus will come.
I want to write this graph by in the form of function. So
Sir, minus आएगा.
Minus आएगा because this is not a sine function, na? See, if this is sine function, so sine function in t by 2 t sine is negative, already negative. Okay, so our output is like this. Our output is not this one. If our output is like this, then we can write sine omega t. I can represent my output by sine function, but my output is not sine function now. Are you getting? My output is not sine function now. So for this is like sine, but this is not like sine. Okay. So if I want to represent my function by this sign, then I have to put minus here. Okay. So now V naught will be minus Vm sin omega t. Is this point clear?
Sir, can you repeat, sir?
Yes.
See, I want to represent, suppose this is my graph. I want to represent by a function. So I know this is sine function, isn't it? ये तो sine function नहीं है. But this is not a sine function. But I know these are similar to sine function. function. So I can represent this function by a sine function, writing minus here. Because if I take minus of this one, this will come opposite this positive. Are you getting this one? If I take minus of this one, this become positive. So that's why I'm putting minus here for t by 2 to t cycle. This is t by 2, this is t. Okay. See, this is very important point. You have to do many questions like this. So you have to always remember, if it's like this, you write sine function output. If it's like this, you have to write for second half, you have to put minus. Okay. So this is very important point, because based on this only you can do many problems. Okay. Some problem came in exam also. So this concept you have to remember. People are writing like this also is a sine wave. This is not sine wave. Okay. Now I know my function. Okay. Now I can calculate my VDC. VDC for full wave rectifier. Again, 1 by t, 0 to t. Okay. Vt dt. Okay. Calculate and tell me how much is coming.
2 Vm by pi.
Okay. So VDC will be what? 1 by t. Okay. I can write from 0 to t by 2. My function is Vm sine omega t, and t by 2 to t. I have another function Vm sine omega t dt. Okay. Now if you solve this one, okay, I'm not solving, already solved one time. Okay, this should come 2 Vm upon pi. This is VDC.
इसको बिना सॉल्व करे भी तो बोल सकते हैं, पहली बार में हाफ
बिना सॉल्व करे बोल सकते हैं. If you know the function, you can say Vm by pi, Vm by, you can add it. Okay. You can take an average directly, you know. Okay. For period, you know already. So you have Vm by pi for t by 2 time. Okay. Another for again you are Vm by pi for another t by 2 time. Could divide by total time t. Okay. This should come to 2 Vm by, is coming or not? 1 by t. So ये आएगा कि नहीं आएगा? So if you take average like this, ft dt, so 1 by 2 t करके से 1 Vm by 2 pi, Vm by 2 pi is coming Vm by pi ना? कैसे आएगा? How you telling? How can you write? How can you do directly? कैसे?
सर हाफ वेव रेक्टिफायर में जब हम t by 2 तक कर रहे हैं तो Vm by pi आ रहा था.
Just give me 1 minute. How to write this one? Okay. ft dt. Okay. हाँ, डायरेक्ट तो कर ही सकते हैं. Okay. Okay. So this is your. Please check it whether the answer is correct or not. Check it.
Yes, sir. ठीक है, sir.
Okay. So I'm giving one problem to you. Okay. You have to solve and tell me what is the answer. Okay. Otherwise, tomorrow we'll solve that one. Please try at home. Okay. Give me just 2 minutes more. I'm giving you a function. Say this is my Vm sine omega t. Okay. Here we have a diode. Okay. Here you have RL. Here you have a voltage drop V0. Here you have another diode RS. Okay. Now you take RS equal to RL. Okay. So better I'm writing both are R. Okay. You write both are R. So you need to find the VDC. Okay. Of output. Okay. VDC of V0. Okay. So this is your homework. Please send me. If you want answer, I'm also writing so that this is Vm upon 2 pi. Okay. Solve it and send me. So any question? Within no question, I am stopping here.
सर हाफ वेव के केस में VDS कितना आ रहा था फाइनल वैल्यू 2 VM upon T ना
फुल वेव रेक्टिफायर में 2 Vm by pi and हाफ वेव रेक्टिफायर में Vm by pi.
ओके सर
Okay. So I'm stopping. Thank you.